So if we were doing this graphically, we would do it like this. The velocity of A with respect to the ground is right here. I'll do it in blue. And we're going to add to that the opposite of the velocity of B with respect to the ground. So let me put in here first what the velocity of B with respect to the ground is. The velocity of B with respect to the ground is this one. So the opposite of that is what? It's this one, right? Flip it. Flip it 180 degrees. And then what's our resultant? I'm running out of colors here. How about green? Our resultant vector is this one right here. That is the velocity of A with respect to B. Okay, that's why we do this little formula. All right, that's why we do this. Because sometimes you have to add the vectors. They're giving you things that you just add together to get the result. Like the ball and the truck, we just added them, right? We didn't need a formula for that. But sometimes you have to subtract one to get the right answer because of what you're looking at. So this formula helps figure out whether you're adding or subtracting. Start out with that formula. Make sure you get your subscripts right. Then go back, see what you know and what you don't know. If you have to flip a vector to get it into the right format, do that. And you can add the opposite of that vector. You can flip it by 180 degrees and then add that. So there's our result. And the magnitude of that vector is well, what is VAG is what, 60? And VBG was 50. So that's the magnitude. And the angle, I'll draw it here. Let's call that theta. Is the inverse tangent of 50 over 60. Whatever that is. So the equation helps you figure out whether you're adding or subtracting. You can do it graphically. I highly recommend doing it graphically, just so you know what ballpark you're in, you know what quadrant you're in, where you're going. And then go ahead and figure out the result. In this case, again, the two were orthogonal to each other, so it was pretty straightforward. You didn't have to break them out into components. That isn't usually the case. Usually you'd break them out into components, get them all the x's in one equation, add them together, all the y's added together, and then you can figure out your resultant from that.